Hi, I'm Ned and I make games. This video is from my live stream over on twitch.tv/NedMakesGames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. I hope you've all had a good weekend. Yeah, mine has been pretty good actually. Well, yeah, I made that announcement that I was going to try and drop the weekly schedule, and so that actually, of course, gave me a little bit of free time this weekend, so it's nice and rested to get back to some more grass, which I think is what we're going to work on tonight. So, I did work a little bit on trying to improve the lighting over the weekend. Basically, I don't think this technique is going to work. So, what I've decided on is basically I want to have two different normals. One normal we'll use for the diffuse lighting, and then another normal we'll use for the specular lighting. And I think that just gives the best effect for grass. So the diffuse normal will point straight up from the terrain. So this will light. So it gives you a pretty good approximation of subsurface lighting as well. And then the specular normal will actually point out from the blade. So that way you can still get nice little reflections. So to do that, I'm just going to create another field here. So we have the blade normal and then the terrain normal. Hey NTT. I hope you had a great weekend. Okay, so yeah. So we don't need these two subsurface. Oops. I guess I can keep the mask suffix there. But yeah, I don't need this subsurface distortion anymore because I think for subsurface, I guess we'd use the, so it's based on the negative light direction. So that way, yeah, if we view the mesh through the light, I guess we should still have some subsurface scattering there. Oh yeah, I haven't been on Discord since I answered your question. I hope that did help you a bit with that random seed per mesh. Okay, so yeah, the diffuse is fine, except I need to use the actual terrain normal here. Okay, and then for the final lighting, we'll add those together. And then for specular, we need to use the blade normal. All right, so yeah, so now I need to just look for any other place that I use this normal and then choose which type. I think, yeah, for real time or for baked lighting, we'll use the terrain normal as well. Okay, I think that's the only other place. Oh yeah, but now the actual grass blades shader is going to complain. So, okay, so the blade normal is this normal world space that we calculate using the normal map. And then the terrain normal, I think, we don't actually have access to that yet, do we? So, I mean, it's kind of, I guess I can delete this whole bit, clean it up. So yeah, this up here, yeah, looking for, well, the tangent to world is not actually the terrain normal because it's it contains like the growth normal. So, or the growth direction. Because I was gonna say I could just calculate the terrain normal using that transform, in which case it would be the Y direction, I think. Or no, I guess, yeah, it would be the Z. Well, let's just see how that looks, and then... Okay, is that what I do here? That's what... Okay, yeah, I have the terrain normal here. I thought I gotten it before, but it's not actually the terrain normal. It's more like the growth direction. Hope that makes sense. But yeah, so I guess regardless, I should pass it through here. Okay, and I think you can have up to 8 text chord registers, so yeah, we're fine. Adding more does kind of impact performance, but I don't think it will be that big of a deal. I mean, this shader is already pretty pretty beefy, so okay. Yeah, so now I can just grab that from here. Okay, and the only other thing I do is I did decide to use the V-face semantic, so we'll flip the normal if we're rendering the backside. So that should make it so that we'll have double-sided specular highlights. Subsurface distort. Oh yeah, so I just need to change this. We can get rid of that property as well. Okay. Duplicated input semantics can't change types. Oh, I forgot to change the index there. Okay. Well, I think it is looking better. Oh yeah, I forgot I can't look at it in the edit view. Mostly we don't have that problem where the side that's lit by the sun is bright like this, but then the side with subsurface scattering is dark. Okay, so what happens if I turn around? Does it stay nice? Okay, yeah, it looks like it. Yeah, because, I mean, grass is mostly transparent, so I want it to look well lit from all angles. But I don't see any specular highlights, so there might be some issue there. One other thing. So if we move this, or the light, to be close to horizontal. Okay, I think that's a shadow. But we should start to see some subsurface scattering. Which I think is this effect. Because yeah, behind me, you don't see it as much because the light, like we're not seeing it through the light. Oops. But if I move, yeah, so it moves with me, and that's just because of how the subsurface lighting works, which is fine. But I don't know, it could just be my texture. But I don't like how some of these blades are all black and then some of them aren't. That seems like another thing that has to do with the double-sided normal. But let's fix the specular highlight first, because that probably, I mean, they both use the same normal, so that probably has something to do with it. Oh, well, the subsurface doesn't use the normal at all, so yeah, it's something completely different. But anyway. Okay, so what I'm going to do is only output the specular highlight. Okay, so yeah, we don't see anything. it could be because of the smoothness. Okay, yeah, I guess it was because, yeah, when I move the smoothness down, you start to see specular highlights. Okay, I think I'm gonna do something to help me test this. I'm going to here I'm gonna contrive this twist angle so it's either 0 or 180 degrees, and that's just so we can easily test the clockwise and counterclockwise winding. So can I? Oh yeah. Okay, so I don't. Yeah, I was gonna see if I could get the grid index of this grass blade. I guess I can just output it here. So it's what type is it? It's a float 3. Oh, okay. I was gonna say, how come it's not an integer, but I think it just works better with the dither function like this. Oh, right, it's not. I was looking for this code, but it's in a different file. So we'll just do something like if our culling results dot grid index dot I guess x, and I'm gonna, oops, sorry, I forgot to silence my phone. I'm gonna cast this to an int just so that it'll work better with modulo. Okay, so yeah, if we're even or odd, we'll either pass or set the twist to 0 or 180, which is just pi. Okay, so this way, I mean, okay, calling results. What do I call it? Oh, just call results. I don't know if you guys can hear that. A cicada or something is right outside my window, apparently. Unexpected token. Oh, I forgot the question mark. Results is used without having been completely initialized. Oh, yeah, I need to store the grid position. Just do results dot grid position, and where else is it used? Right there. No matching 3 parameter function. Oh. Okay, so this is different than the index because this position, yeah, is not clamped. Okay, so yeah, I kind of messed that up. Oops. So, I guess I need to output another value from this. Or I could just calculate it from the grass grid. That would kind of make sense. Okay, I'm kind of spending a lot of time on something that was supposed to just be for testing. Okay. I guess it makes more sense to be right here. So then the grid index is that. So I don't need to output it, and I don't need the grid position for anything else, right? So I can just pass the grid index in. Oh, okay. Well, this actually simplifies stuff because I don't need this grid position at all anymore, I don't think. Anyway, okay, this doesn't break everything. Okay, so... Okay. Well, they're all rotated different, or away from the camera. So I think I'll just rotate them 90 degrees more so that I won't have to move the starting position. Okay, so that would be pi divided by 2, and then pi times 3 divided by 2. Okay, so now they're all facing the camera, but yeah, I don't see any specular highlights at all. Okay, well actually... Okay, so they're still there, but they're only when they're facing away from the camera. Okay, so that tells me that we definitely have an issue because there's only specular highlights on one side. Well, maybe not. Because over here... Okay, you know what? I should also remove the curvature now that I think about it. Oh. So now it's symmetric. Okay, I think it's... Well, wait, is it... It's kind of hard to see now because they're all black, but... Is it skipping every other row? Maybe it is, actually. Well, one way to make that more obvious is if we lower the amount of grass blades. Okay, yeah, it definitely is skipping every other blade, so that tells me that they're not double-sided. Let's also, just to make this even easier, I'll set the specular mask just to 1. So that way the entire thing will be able to get a specular highlight. Oops. Okay, and then the light. Okay, is that correct? It seems. I think that the normals might be reversed because it seems like. Because if I'm facing this way, the light is moving down, then, or the light is moving behind me. The specular highlights shouldn't be on this side. They should be on the other view because the highlight has to like bounce off of my eyes or off of the object into my eyes, but the light isn't flowing that way. I guess I can make it even more obvious if I set the X rotation to 0. Yeah, so when I face this way, I shouldn't get any specular highlights, I don't think. So yeah, the normal vector must be reversed. Okay, yeah, I'm glad I tested this because I was wondering if this would happen. Okay, so do I need to so I need to invert that, I guess. Okay, yeah, so now I'm facing the same way, and then when the sun set to 0. Oh. So now it's going back. Okay, what am I doing wrong here? Okay, well, I mean, it's obviously something is wrong here because every other row is not getting any specular highlights, even regardless of the sun issue. So they should flip because of the Z face, but I wonder if, or V face, but I wonder if it's set to like 0 and 1 instead of -1 and 1. Okay, assumed. Indicates back-facing primitive. A negative value faces backwards, while positive value faces the camera. Available. Oh, so I should use is front face instead for 10 and later. The triangle is front facing for lines and points. Is front face has a value true. The exception is lines drawn out of triangles. Okay, well I kind of like V-face better, but I don't know, maybe it's not supported. Let's try it. Oops, I didn't want to do that. Because since this is Boolean, I'm gonna have to do a branch, but flip normal equals okay, so if it's the front we shouldn't flip, and then multiply that. Okay, it still doesn't look right, which is kind of funny. So what if we just don't ever flip the normal? Does it work right then? Because that would also be weird. Okay, well it looks different than I had it before, but still the different sides have an effect, which is not what I want. I'm trying to think what the easiest way to try to debug this would be. Do I need I don't think I shouldn't flip the tangent. I don't think. I guess we can try that, but I'm pretty sure that's not it because the tangent vector, at least in my, okay, well the tangent, yeah, this is in world space. So the tangent vector always points to the right in world space, so I don't think flipping it will help. Okay, well maybe it does. Oh, well maybe, okay, yeah, see I bet this tangent vector was, well that means that the tangent vector up here was incorrect. But I guess we flip it down here so it doesn't actually matter. Oops. If I turn around, okay. And then set the directional light. Okay, well now I don't see anything. Maybe that's not supposed to be negated. Okay, well at least now we got rid of the every other blade being incorrect. But it seems like, yeah, it seems like it's the wrong side. So if can I fix that by just negating this? I mean, this doesn't seem like it should be something I should do. Okay, no, that just turns everything black. So what I'm expecting is that this front area should be, I should be getting highlights from that. Which I do when the sun starts to rise, but... yeah, I'm getting specular highlights when the sun is below. But only where it's not shadowed, I guess. Okay, so obviously some of the stuff... oh, it'd probably be easier to test also if I turn off the wind, now that I think about it. vector that's orthogonal to the normal to be the tangent vector, and then, oh yeah, then I take the cross product with the normal vector to get the tangent world space, and then do another cross product to get a bitangent, and so that kind of, it's just random. I don't think I need to normalize here, but I guess I'll do it to make sure that's not the problem. Okay, so yeah, this is how we was before. So it looks about the same. Although it seems to be stronger at the sides instead of straight ahead. That was probably just because of the angle of the sun. It's like that, yeah. It's like kind of reverse. Like I said, it's reverse of what I would expect. Alright, let's keep on trying stuff. Yes, I'm pretty sure it's nothing here. Yeah, and you shouldn't need to normalize this because it's already going to be normalized because the cross product is, the length of it is equal to the length of both of the vectors plus the sine of the angle between them. And if these two vectors are already orthogonal, then sine is equal to 1, so you shouldn't have to normalize that. But, so I think that the bug is somewhere in here. I'm probably getting like the left-hand rule mistaken. So yeah, if normal points upwards in the tangent, okay, then that means that bitangent, I'm trying to do, I know you guys can't see, but I'm trying to do the left-hand rule. Okay, so the bitangent points up, and then the tangent points. Okay, so yeah, so if the bitangent points upwards and the tangent points in the positive x direction, then that would mean the z would point towards the camera, so that would be the negative z direction. So maybe I do just need to negate this after all. Okay, well, I think this is right. I'm kind of tired of working with these. But yeah, it looks about right. I thought I tried this before and didn't like it, but it jumped there. But then when this comes around to the other side, yeah, and then of course it is a little confusing because it also depends on where you're looking at it. Okay, but I think this is about right. Okay. So we can try let's try doing the diffuse now. So I'm going to turn off that. Yeah, and we'll just use the diffuse lighting and see how this looks. Okay, so the good thing here is that, yeah, it's not different per side, but that makes sense because the terrain normal just always points upward. And then yeah, so that's fine. Okay, so let's just try the subsurface lighting now. And then we can combine everything together. Okay, so what it should look like is when we're at the sun, or we're standing between the grass and the sun, we should see the subsurface lighting. Okay, you can kind of see it. Well, I guess, yeah, that's pretty good. And then that's the shadows coming in. I think that my subsurface mask is a little bit too permissive, or because it doesn't really look any different than normal diffuse lighting. Let me can edit that real quick. Oh yeah, it's pretty, yeah, pretty, so since this is mostly white, it just means it's gonna lighten the grass up completely. So I think I want to make it darker. So we want some of the light to pass through, but not everything. Yeah, and then we want to block out areas around that thick vein in the middle. Let's see how this looks. It might be a little too dark, but okay, that's definitely better. Okay, so now let's add everything back in. And fix up here. So we'll get the normal specular strength. Alright, so this is mostly diffuse lighting. And then when the sun sets, the grass will get darker, except we start seeing the subsurface lighting. And if I turn around the other way, we shouldn't see, I mean, it should be darker on the other side because we won't see subsurface scattering on that side, except, oh, but I think that's just diffuse lighting. Yeah, because it's brighter over here and we can see more contrast. Make it really extreme. Yeah, so here it's dark on that side, and then but on this side we can see some of the subsurface scattering. So I'm pretty happy with that. All right, let's add back in the wind and make sure that doesn't mess anything up. I'll set that back to 1 to make this obvious as well. Okay. Yeah, and So yeah, we're getting some specular shines too. Although it's a little too strong right now. Let's just check everything again. And then on the other side, we should get some specular highlights, maybe. Very dark. I'm getting highlights here, so... Oh, well, you know what? The specular highlight, yeah, is multiplied by the diffuse lighting. So yeah, when there's not much diffuse, you won't get much specular, so... But yeah, we can see the shine. So it's still working, it's just not going to show up, which I guess makes sense. Okay, well, I think I'm happy with that. So, okay, what next? Okay, so the main things I need to do for this project is I need to make the height map based shader for terrain, and then also try to add baked lights and shadows. Let's do the terrain shader first. I think I feel like that at the moment. And so I remember last time I was worried about what I'm gonna do if you rotate this, but you can't rotate Unity terrain, so I don't really have to worry about that. Another thing I thought about, because like the point of using this instead of just duplicating the terrain or something is that basically if you only have grass on a part of your terrain, you don't need to like draw the entire thing. So the UVs for this, well, I guess it's fine. It'll just contain like a sub rectangle of this actual height map. So I guess I'll just need to make a C# script that will somehow calculate that. So in that case, I shouldn't transform text because we'll we'll end up messing up whatever values we'd set in there. Okay, so anyway, so the left height, we got height at different. Okay, so I messed this up. The Y position should go in the second coordinate. So here we're trying to calculate the, oh yeah, the tangent and the bitangent. And then I guess also the normal. Okay, so something like, well, the normal we can calculate basically 3. It goes like from the left height to the right height, and then we also add double the texel size. But I guess we need to do it in world space, so we kind of need to know the size of a texel in world space. Oh right, that's what I was worried about how to figure out. I think we'll. Oh, that's the clip dimensions. I think maybe I'll just have that also passed into this input vector. trying to think. There's not a way that I can really figure that out in this shader, because I would have to know. Well, I basically have to know the dimensions of the texture and world space, so we'd have to get that passed to us anyway. So let's see. So that can just all be stored in this UV and pixel size world space. Okay. So I'll just pass that through here, and then I'll need to have another. Okay, what was it? Was the clip space dimensions? Oh, right, for a blade of grass. So I still need that. Okay. So dimensions are, I'll just call this blade dimensions clip space. We can pass that right here, and now we can just pass the UV and clip dimensions directly from the attributes structure. Okay. Okay, so this should have been a float 2, actually. That would have been an annoying bug. And this will be float 2 pixel size world space. Okay, so the U vector is a float 3. So it's the pixel size world space times 2. And then nothing in the Y. Oh wait, so the, yeah, because unity Z point or Y is up, so Y actually is the difference in height. So this should point from right to left, which means we've got to subtract like this. And then nothing in the Z direction. And then the V vector is the same thing, except X and Z are flipped, and then we use pixel size dot Y, and then it goes from bottom to top, so up minus down. Okay, and so this is a float 3. So the cross, or the normal, will be the cross product of these two. And we need to normalize it. And so out, float 3, normal world space, out 3 tangent, and also the bitangent. Okay, so is the tangent, are the tangent and bitangent just these vectors? Well, no, because they might not be perpendicular. So if I want the tangent vector to point like in the U direction, then that should be something like vector with our newly created normal vector. And then the bitangent is just the cross product of those. Yeah, this should work. There's probably, I wonder if there's a way that you can like not use so many cross products, but we can look into that some more later. Do I? Yeah, I don't need to normalize this actually. Oh yeah, I do, because the U vector wasn't normalized. So I was gonna say because U vector and normal world space are already orthogonal, but okay. So after we know, okay, so I was gonna see, like, have I done everything I need to do here? I think so. So it took a control sample. And oh yeah, so up here is where this next part comes in. So we will get basis vectors, and we pass in the UV and the texel size. Let's see. Oh, I didn't rename that. Okay. I was gonna say, I hope I didn't edit the wrong file. So yeah, we have the UV already, and then we can just get the texel size from here. And then just out. Normal. Train tangent. Bitangent. And then we can just pass those here. Okay. Is that? In the center position, which is just the snap position, I guess. Why does it need to know that? Yeah, it doesn't need to know that. Oh, right. And so, okay, these heights, I also need to scale this by like the altitude as well. Yeah. So, because we have to translate these height map heights into world space, and we do that by multiplying it with the altitude. Okay. I don't need that anymore. Okay. This part is getting the tint, which I think is fine. And then this part we're getting the dimensions, which is also the same. Oops. Okay, and I was getting that position. Yeah, which I don't have to do because we already calculated that. Oh, I guess we didn't. Okay, so actually we'll set... So we already set the Y to the height up here, which is what we want. But we gotta set the X and the Z to equal the snapped positions. Okay, and then this part is what sets up all the data for the sprout. And I think this is mostly the same. Let me... I think I'll just copy and paste this in case I've changed anything. Oh, well, I need to get rid of that. And also, yeah, this part, because we're done testing that. Okay, so is there anything I need to change here? So we set the sprout position, and then we add the scatter, which is all the same. And then a normal. Okay, so I don't have a normal map. So I don't have this tangent to world vector. So all I have to do is pass in the terrain normal here. Dimensions is good. Hint, wind multiplier, bend angle, twist angle. Oh yeah, I also want tessellation for the grass, so this is good. You know, I should probably... Yeah, I don't like having this function. Yeah, I should move this into the common file. Get grass tessellation. I don't know. I remember what I need to give it. There's the maximum LED and then the current LED. Okay, yeah, this will be better because now if I need to change that function, I don't have to do it in two separate grass files. Okay, so I think we're done. Okay, syntax error, unexpected token. Oh, I just forgot a semicolon. UV and clip dimensions. Oh yeah, this should be that UV and texel size. Valid subscript. Oh yeah, and this should be different because I moved the blade dimensions into a different variable. Get basis vectors. Okay, so yeah, it's saying that there's no zero parameter function, which means that... Oh yeah, I don't have to put the out keywords. That's only for C#. Yeah, but usually when the shader says that, it's because it doesn't recognize one of the variable names passed to it. Normal map. Oh, okay, so yeah, I don't have normal map for here, so I can get rid of that part. Okay, get height, implicit truncation of vector type. Oh yeah, these should... Oh yeah, this should be a float 2 there. Should I just... Yeah, this isn't really needed, but I'm just going to add an abs here so that this thing will stop complaining. Let's see. Well, it's not going to work yet because I don't have a height or an object set up. Let's make a height map real quick. Yeah, I want to edit this some more, but we'll wait. New substance. Do terrain height map. Probably I'll want to find one online that looks better, but for tonight this will be okay. Okay, so let's just do some random noise. How about... Well, I guess I shouldn't be too random. Let's do Shape. Okay, that looks fine. And then I'll just add some noise to it. Actually, yeah, this should be the foreground because I'm gonna blend it on top. Maybe. No, that doesn't look right. Okay, I don't know. That's totally fine. Was it better? I didn't like the multiply because it didn't have anything out on the edges, but okay, I think max was fine. All right. Anyway. All right, and yeah, we should output it raw. Right. And here, I'm gonna turn off sRGB. Do we need maps for this? I'm not sure actually. I'll just leave it on for now, and we'll put clamp. I kind of feel like, well, I don't know. We'll see. I don't know if we need maps because, or actually, I always sample it with LOD, or this is the wrong thing. Yeah, I do sample at LOD, but technically we could use maps. I'm not sure what'll look the best. I think if I have maps, it might kind of like, well, the height will change when you zoom in and out. So I'll have to see how Unity, well, what matches the Unity terrain the best. Okay. Let's make material. Okay, so for the main texture, this is the control texture. I'll just put white, and the tint I'll also just put white. Okay, the height map, the altitude. That's fine. Leave that 0. Yeah, let's just leave default stuff. We can test it when we got it running. What was... So it's like 0.24. Alright, so to test it, let's make another soil like this. Oh, it's really, yeah, huge right now. I guess I'll just leave it on top, and we'll just turn off the other one. So I'm not sure if that's a good thing. Oh, well, the texel slide's not going to be set correctly at the moment. So, yeah, I probably... Oh, I'm surprised something actually grew. Is that from this? Yeah. Okay, well, so far it seems to work, right? Although, yeah, it's not doing anything with the height, and that's because the terrain UV is set to 0. Or the terrain texel size is set to 0. Alright, let's... I'll just make a simple script for now. Because the hard part will be synchronizing this with a Unity terrain object, I think. So, terrain, soil... Okay, I'll just call it that for now. Okay, so I mostly just want to set the text chord to be, well, I guess I'll need to see the dimensions of this object and then set the text coordinate. Okay, so for, oh, I've got to do vector for actually. V's equals new. First I need to get the mesh, so I need to require component type of mesh filter. This could be something that we could do at edit time actually. Okay, so mesh filter, and then we get the shared mesh UVs equal new. So it needs to be the same size as the vertex count. Okay, and so the dimensions of this, I mean, I guess we could loop through every vertex and find it that way. I mean, that would be the easiest or the most automatic way, I guess. Private float 3. Oh wait, doesn't, yeah, the mesh already has a bounds class, doesn't it? Oh yeah, okay. Yeah, so I don't have to calculate that myself. I can just use the bounds and then multiply it. What do we... Okay, so yeah, rotation and scaling. Well, we could support scaling. I wonder if scaling, if you can scale terrain. Okay, so you can't really... I don't think you can scale it in the transform. Which is nice, so that way I don't have to worry about that. Okay, so I don't need the vertices. I can just use the bounds. Bounds equals mesh dot bounds. And since it can't be rotated, we know we could just get flip 2. xz size equals bounds dot size xz. Oh yeah, it's a vector 3. I wish. I know it'd be a big thing for Unity to do. Oops. But I wish that they would convert everything to use the new mathematics structures. So so much nicer to work with. Why is it not like that? I converted it. Oh, I think I have to do another parentheses. Okay, so there, that's the size and world space. So now we just need to get the texture out of the mesh. And then divide. Oh, okay. Well, yeah, the width and height of a texture in UV space is just 1. So I can just take or invert this. So that's nice. It's fully released too. Sorry, NTT, I'm not sure what you mean. Oh, the mathematics. Yeah, the mathematics library. Yeah, it is fully released. I wish that they would do it, but I know it's got to be a lot of work to refactor everything to use. So I don't entirely blame them, but it's all right, NTT. Okay, so anyway, that means that to pixel size and world space is just the xz size, or 1 divided by that. Does that work? Okay. So now all I need to do... So I gotta get the original UVs out of this mesh. Okay, which is a vector 2. Right, and then for int I equals 0, I less than length. Then we'll set the new UVs to be equal, so the x and z coordinates will be the original UVs, which I guess float to original UV equals original UVs dot I. I'll float for. And then we can take the texel size and world space. Okay, does that work? Okay, so I guess I don't have a constructor that works like this. It's not a huge deal. Oh, I think it's because I put that plural on there. Okay, I'm making a bunch of little mistakes. There we go. Now we just need to upload this back to the mesh, and we can't just bind or set it here because this UV is a vector 2 or an array of vector 2, but we can call set UVs, and then we want to put it into the text chord 0, and they let you upload arrays of vector 4s with that function. Okay, and then I just need to re-upload this to the mesh filter. Okay, so I think this should work. Like I said, you could do this at edit time. But just for simplicity tonight, I'll just do it on the start function. Okay, so Oh, it's upside down. Upside down and right side up. Also really bad frame rate. That's funny. I wonder what's causing that issue. Okay, let's make everything. Okay, no, that can stay. Well, it's already at 1 blade per unit area, but just since the frame rate is so bad, I want to not have too many blades open. Oh. That's funny. Yeah, I should probably... I think, yeah, the closest power 2, I guess, was 0. I should make sure that the... we should have like a minimum of 2 here. Oh, that didn't fix it. Texture size. Okay, well, did we get that debug? Oh yeah, so the texture size is 0, 0, even though I set the max. Oh, yeah, I called the wrong function. It should be maximum. Although something is still wrong, obviously. Okay, so I can't see it at, or the texture at all here, which is kind of funny. Yeah, I have the grass terrain visible. And then, yeah, here there's a bunch. So there's some that's right side up, but then some that seem to go way outside the bounds that are upside down, which is kind of funny. And yeah, something is wrong because it really kills the frame rate. Uh, Trying to figure out what could actually happen that would make the that would make the grass spawn upside down, unless I... Okay, maybe I need to negate the cross product there. But there were some that were facing the right way, so I don't know. Okay, that doesn't have any effect on it. Yeah, something is weird going on, because even though the texture size is 2 by 2, Meaning we should only ever get like 4 blades. There's a lot more that are spawning. Did I mess something up with the other grass? No, it still works. I mean, obviously there's not a whole lot of grass plots because I set the blades per unit to 0.1. No, it's still fine. Well, I mean, that's good. Okay. Yeah, I don't know why it doesn't. So what about if I just set overhead get height always return 0? What would happen then? Oh, also, yeah, here I should really add the height to this position. I don't think that was the problem, but okay. That is, well, I guess I kind of fixed it, but I don't know what all these phantom upside down grasses are, and they seem to like be in view space as well because when I'm moving the soil around. Oh, okay. I think I put the, yeah, okay. I messed up the materials on here because this thing should have actually been a visible material for the ground, and then this one was supposed to be the soil, but I flipped it around. But why? Okay, but the grass, yeah, that might be the issue actually because the grass camera shouldn't even see this object, so I'm a little confused about that. So if I turn that off, what happens? Okay, so why does that happen? Because this isn't even in the correct layer for the soil camera to see. Yeah, the culling math, it should only see objects in the grass terrain. Oh, but you know what? Yeah, even not, so the visible camera was actually, okay, yeah, that was the issue, because even though, yeah, only the soil camera should see this, the visible camera still renders this shader, and since it was on the visible layer, the visible camera was triggering additions to the sprout buffer, which, yeah, is kind of like undefined behavior. Okay, so that's kind of an interesting thing. Okay, so yeah, this terrain should have the visible soil material. I'll have to make a note to make that very clear in my tutorial. Let's see. Let's add another toggle here for, I don't know, notes. Make it very clear to set the all soil materials and its own are in their own layer. Invisible to the main camera. All right. Okay, so that fixes a lot of the weird issues I was seeing, I think. So if I just add this height map soil here, okay, yeah, so now it should work. We don't see anything, but I think it's because the soil is. Okay, well maybe not. I was gonna say it's because maybe the player is too low to see the soil. But yeah, I don't see anything at all. If I change the altitude. Oh, well the height always returns 0, but I don't think that would explain why I don't see anything. Okay, so it is upside down. Also, yeah, the altitude doesn't affect anything. Okay. The frame rate, it's still not bad, but at least it's not down into the double digits like we had before. That's just because the buffer is not supposed to be written to during the visible cameras drawing, I guess. Okay, so oh right, so I need to add the altitude here. Should I multiply it here? I guess it doesn't make a whole lot of difference. Well, I think it'd make more sense if I multiply it here, but technically where it's less efficient, but yeah, for the tutorial I try to keep things as clear as possible, so I think that probably is a little bit more clear. Okay, so we still have it upside down, but at least the height map is kind of working. So since it's upside down, I must need to, oh, I had negated that to try to fix the problem before, but I think it, oh no, it's still upside down. Oh, because I was negating the bitangent, so I need to negate that. Did I like do this backwards? I don't know. Because the right, you subtract. Okay, so I guess I can do the left hand loop rule again. Well, based on. Okay, so I think, yeah, I do need to flip it because I think this should maybe be going the other way. All right, well, this works. So if I flip the altitude around, okay, the only issue I guess is that it's kind of too big to actually, or the terrain object is too big to see the height map. So let's just make our thing a lot smaller. I think that's too small. And I'll just move it ahead of the camera. So now we should be able to see the entire thing. Okay, so you can kind of see it has a little a hill there. There's not enough detail for you to see the cracks that I added in it with the noise, but okay. So it doesn't, like, they should grow like normal to the terrain, so Yeah, I think my code to calculate the normal isn't correct. Yeah, because we get that there. But this always just returns up, I guess. It should return. Yeah, like I said, like normal to the actual terrain height map. Okay, so if this always returns upwards, then that means that these u and v vectors probably always point right and down or something. So that would explain to me that these height values are equal, maybe? Maybe if I make see, forget how you do it. I'm trying to change like the dimensions. I guess it's right here, but I wanted to like set the actual value. Okay. Let's do it 32 by 32. So now hopefully I want to test if it has something to do with the difference in pixels not being high enough. Let's turn off this bend angle again so I can really see. And I think I'll turn off wind again. Okay. It sort of looks like the normals are different. So if I mean, I should be able to tell if I, okay, so they are, yeah, but they're pointing opposite again. So I think I did calculate one of the vectors wrong. Because yeah, when I turn this off, they're pointing like along the terrain and not, or the normal's pointing along the terrain and not opposite, or not normal to it. So what am I doing wrong there? Okay, let's move back to that and maybe negate these vectors and see how that looks. Okay, so they're still upside down. And then if I negate this again, then I think it'll be back to what we had before. Alright, so let's just do that. Okay, well that seems to help a little bit. Okay, so it looks the same. And then yeah, when I get it both, then it was upside down. What am I doing wrong here? This, in my head, this math seems correct. Because it's like basically the same thing I did in my sand dune material. Okay, let's see. Well, let's just find an algorithm to do it. Calculate normal and tangent from height map. So vector 2 center left minus center right. Okay, so why are the x and the y both 2? Did they, maybe they did diagonally? I feel like, yeah, I'm only moving, I'm not moving diagonal, so maybe I should though. Okay, let's try that. I don't, yeah, it doesn't feel like it make a big difference, but oh yeah, this should be y. Okay, is this still correct? Like these should be opposites. Oh. Yeah, because they need to do let's do negative, positive, 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 negative, negative, and positive, positive. Okay, so I have 2 of that. So what am I missing? This one should have a negative there. Okay. So starts on the left. Like okay, some of these I might need to be flipped, but it's been a long day and let's see if it works. Okay, so yeah, that's kind of all over the place. Let's just try turning these around. With my luck, I probably had one of them correct and then one of them incorrect, but yeah, now that I think about it, for my doing it diagonal probably is better, but Okay, well, it's still not working correct. Vector 3s. Okay, this is confusing. Lots of ways to solve this problem. That's basically what I'm doing. Okay, maybe I need to. I think I need to get out a diagram because it's I'm having trouble visualizing it. Oh, Inkscape. It's a wonderful program, but the interface is there's a lot to be desired. All right, so we have a bunch of squares. Okay, so this should be -1, 1. And then this one should be +1, 1. +1, -1. And then -1, 1. Okay, so we want to subtract. Okay, so based on the left-hand rule, we want the vector. So if we want the vector pointing outward from the surface, we need to take the cross product of this vector. I don't even have an arrow. And okay, so now I've lost it. And this vector. Okay, so that means I need to subtract. So this vector goes from negative x to positive x, and then positive y to negative y, and this one goes negative negative, positive positive. Okay, so you need to subtract the final, or to get this vector, I subtract the start from the final position, I think. Anyway, so okay, so this one, so this first one goes from here to here, so it's going to go in the negative z direction, but the positive x direction. So I need to subtract that, and right, it starts at negative, positive, positive, negative. So these should be flipped. Okay, and then the next one goes from negative, negative to positive, positive. So both positive. Okay, and I think that's right. So hopefully this will Okay, so now they're upside down. So if I flip this, hopefully that'll give us the right. Okay, but they're still like pointing along the terrain and not opposite, or not normal to it. Ugh, I don't know. I think I might fix this later because it's too late to do all this vector math. Anyway, so let me just add a note. Fix the normal directions. Besides that, everything works. Okay. So now I need to try to get it actually like to synchronize with Unity terrain, which I don't have a whole lot of experience with, so this might be interesting. Okay. Yeah. Most of the projects I've done haven't really had to use it, so. Okay, so I don't care about the collider really, but I'll just leave it there. So no, we don't need to do that. I want to. Can't you like import a height map somehow? Trying to make this compatible with Unity terrain, right? Yeah. Or at least, I mean, you can't really, well, from what I know, you can't really write a shader for the terrain yourself very easily. So I thought it'd be easier just to make another little object that you'd place underneath the terrain. But now I've got to get it to sync up. Okay. I thought there was some way you could import. Oh, this is the wrong thing. Grass, terrain, search, assets. Oh, it's a .raw file. Can you export a .raw file in this? Okay, what is a .raw file? Unity terrain .raw file. It's a good practice to store height map. Terrain tools that affect height such as blah blah blah. Unity represents the height of each point in terrain as a value in a rectangular array. Yeah. Good practice to store height maps as raw files. A raw file uses 16-bit grayscale format that is compatible with most image and landscape editors. The Unity editor enables you to import and export raw height map files for a terrain. To access the import. Okay, well, unfortunately, Substance Designer does not export in a .raw file. Hopefully, I can just import into GIMP. Kind of annoying. Let's see. It's gonna take a little bit to load this, probably. But yeah, so hopefully I can import this into GIMP and then export a .raw file. Yeah, like I said, I haven't really had to use Unity terrain. Most of my projects are kind of like cell shaded, so I usually just use mesh terrain and not the Unity's terrain tools. But I know that lots of people have asked me about using grass on terrain, so I want to try to support it. It can't open this ping file. I why is it not? Oh, it's sorted upside down. Okay. Train. Fucking crashed. What in the world? Why do I always have this kind of stuff on stream? Okay. Let me just try to reload it. Sorry about this. I don't. I just used GIMP the other day. I don't know what in the world's going on. Or maybe it's because the PNG isn't in sRGB or something. That could be because I told Substance Designer to export it in .raw, or in not .raw, but in raw format. Maybe GIMP doesn't like that. Let's try it again. Nope, still not working. Does I mean, is it all? Let me try to just open another PNG file. Okay, yeah, so GIMP doesn't want to open PNG files. Let's I guess we can do a TIFF. Okay, so it's still, yeah, I don't know, I must need to reinstall GIMP. Well, I can't do that on stream, so what am I gonna do? Let's see. Substance Designer export .raw file for Unity. Yeah, it's just talking about raw export versus sRGB, which is fine, but I need this .raw file that Unity says everything supports, but okay. Maybe is there some let's see, can I convert .png to .raw? Maybe there's some website I can. Okay, convert PNG to .raw for free. Hopefully this website's okay. So we're gonna navigate there again. Video projects, grass, train. Okay. Let me grab that real quick. Alright, so it seems like it's a .raw file. And Unity doesn't even... They don't even have an asset importer for it. That's kind of funny. Anyway, okay, so look at the Unity terrain, and then we'll import a .raw. Press. So terrain size, let's just make it, I guess this is in world units. Let's make it pretty small. 50 by 50. By 50, I think. Okay, well that didn't work because it's not, I don't see any height to it. Well, I mean, obviously Windows sees the correct data. Don't know, this is website probably doesn't really say anything about it. Okay, well that's not correct. Okay, maybe I'm supposed to, in the resolution, I'm probably supposed to put the width of the texture, which how much was that? It was 32. That doesn't, that's not it, I guess. Okay, I thought this would be a little bit easier to do. I guess Unity, they just want you to use their painting tools to raise and lower the terrain. Which I guess we can do, and then I can export. Oh, except now I'm gonna... Yeah, can a shader even... This might be a problem. Because if we have to have the height map in this raw format, and Unity doesn't even really import it, can a shader even read it? Let's see. Well, the soil will let me drag that height map into it. No. That's not a good thing because now for the tutorial I'm gonna have to have somebody's gonna have to well, I guess there's already one like step separating the terrain from this because you have to export this height map every time you change the terrain, which I already thought you'd have to do, but now you have to export it and then convert it to another file, which is really, I mean, yeah, it's not, I guess it's not the end of the world, but there's some, so I don't think, the problem is that for this system you have to be able to add, well, you either have to make another copy of this terrain that uses a grass shader, or the grass soil shader, which I think having 2 terrain objects is kind of overkill. Or you would have to somehow add another shader pass to a terrain shader, which is difficult to do because Unity doesn't let you access the actual terrain shader, so you basically have to copy and paste it and then add the grass shader pass. Yeah, so that's kind of where I'm at. I'm trying to... They've made it pretty difficult. Alright, well I think... Yeah, I'm gonna have to take some time, I think, to think about the best way to do this, because I don't really like either of my options to support Unity terrain. But I know people are gonna want it, so I feel like I've got to do it somehow. So yeah, I think I might switch to another project for the rest of the stream. Just to let me have some time to think about this. Yeah, I don't know. Well, okay. I guess let's well, this also might not be super easy, but let's just put a pin in this terrain thing and work on light mapping, because at least hopefully I'll be able to get that to work. Okay, so basically what I need to do is the soil shader will pass light map data to the grass, because the actual grass blades can't be light mapped because they don't exist at edit time, or can't be added to the light map. So they'll use the same light as the soil. No, I don't think... again, I haven't used light maps a whole lot either, so this might be another interesting topic, but I think in order for something to be light mapped, it has to be marked as static, which is fine because this soil will be, but I'm not sure. Let's see, so light mapping. Okay, so it does work so far. I'm also afraid that yes, that this, since the visible soil and then the grass spawning soil are basically in the same position in space, that the light mapper will like have one occlude the other. And I'm not sure if that's possible to avoid. If that is the case, then it's going to be even more difficult to get light mapping to work, because I'll have to like copy the light map UVs from the visible object onto the soil object. But yeah, let's hope that's not going to be the case. Anyway, so rendering, lighting, tell it to generate a light map, and hopefully this won't take forever. Let's see. Okay, now it says it'll take about a minute. That's not too bad. Material render job skipped out of system memory. Really? Oh no, it's still working. Okay, maybe we can't do this while I'm streaming. I don't know. I have I have quite a bit of graphics memory, so okay, well, force stop then. Okay, it seems like it's just hanging. I'm gonna close Maybe this won't be something we can work on tonight either. I'll try it one more time. Let's just do it with like no meshes. Maybe, yeah, because that mesh is really big, so maybe that's the issue. Okay, so that worked at least. I thought I could see the light map. So if I turn this back on, initialize light might. Okay. Well, it's kind of weird. It doesn't like. Okay, I wonder if it's my grass object. I'll just do the normal visible mesh and see what happens with that. I mean, I only have the sun in here, so it shouldn't be that hard to do the light map. Okay, so I'll turn off the grass soil. Okay, this is going to take an hour to finish, but no, that's not right. Okay, so that's interesting. I think it's just because this object's so big. Can't remember a time where you didn't have issues with light maps. Yeah, I know. They always cause problems. Yeah, so I know people are going to want them, so I'm going to try to support it, but again, I think it's going to be a little tricky. Okay, well, at least it compiled this time. Okay, now we can see the light maps. Let's move that right there. And I think, don't they? Oh, maybe that's in the new version, but there's... not what I want. I thought there's some way that you can, like, visualize light maps, but... Let's see. Oh, here. Baked light map. Okay, yeah, so everything's just blue. Because, yeah, right now it's just using the sky. Anyway. Yeah, oh, I need to do... Yeah, shadow masks. I need to... Well, I guess it's kind of the same system. Anyway, so I think this is right. Okay, so it's something to do with my other object that it doesn't like. So what happens? Yeah, because when I turn it on, it's probably... Oh yeah, it's probably because it doesn't have a meta pass, which you need for light mapping, but I kind of figured that without a meta pass, Unity would just skip it, but apparently it uses all of its memory or something, I don't know. So, but yeah, so what I want to do is it inserts lightmap textures into text chords 1 and 2, or lightmap UVs into text chords 1 and 2, and then I was going to pass them to the sprout, and then we would just have each grass blade sample from that. So it's not perfect because the grass blades, well, I guess the bigger you make the grass blades, the more problems there'll be, because basically they're going to be lit all using the same illumination, because it's just based on one point. But I don't think, well, I mean, technically you could do it another way, but I think it, well, no, because you'd have to like guess the size of a grass blade in the lightmap UV space, which I don't think is really possible to do, because that's what the lightmapper calculates itself. So that is one drawback to this grass system, but I mean, if you make your grass blades small enough, I don't think it will be that noticeable. Anyway, that's the plan. I don't know even if Unity will, like I said, I'm afraid that the visible soil will occlude this shader from the light mapper, which will kind of destroy all my plans. But anyway, so I need to add a meta pass, which I thought you only had to do to, well, I guess you have to do it because that's what tells the light mapper like your albedo color. But yeah, this doesn't really have an albedo. Yeah, I kind of just want to like get the light map data from it. Well, hopefully, let's just try it out and see what happens. So I have to, like the lit shader, I need to add another shader pass. This is, okay, this is the graphics buffer, which is for, I don't think it was implemented yet, but I think it's for deferred rendering. Okay, depth only, depth normal. So yeah, so the meta used during, it's only for light map baking. Alright, so what's it do here? So it sets off various shader features for like specular and emission and all that. But I don't have to worry about that. And then it grabs this from the lit meta pass. So let's see what is in there. Okay, so vertex, meta vertex position. Gets a bunch of UVs. What are all those? I guess that's light maps. Oh, probably this writes into the light map. Hi Pall Mall Rockstar. I'm working on some grass. Trying to kind of finish up the last couple kind of difficult problems I'm wrangling with, but this is basically what it looks like at the moment. Alright, let's turn some wind back on. But the cool thing about this grass is that it's basically controlled by a camera, so wherever the camera can see, grass will spawn. So like right now I'm moving the camera away, and then you can put other blocks, and then grass will spawn on top of the block. So that's pretty cool. I've got like most of the main systems done, but I'm trying to get light mapping to work with it right now. Alright, so where this meta vertex position. So now I've got to try to figure out where this is defined. So the first clue is that this includes this meta input file, so maybe it's in there in this shader library. Yeah, URP. Okay, so thankfully this does have those files. So meta vertex position takes in object space position and UVs 1 and 2, which I think this is the light map UV, and then what is, I think it's like the static light map and then a dynamic light map, I think. What is, oh, this is the scale and transform, I think. Yeah. You're working with HDRP shader graph right now. Trying to decide if you should do universal since there's more stuff out there on the web. Good HDRP. Yeah, I think yeah, a lot of people I think have chose URP over HDRP just because it runs on a wider variety of platforms. At least that's one of the reasons I chose to do it. But I think Unity kind of is pushing for HDRP, so I don't know, in the future that might change a little bit. I hope to cover it more soon, but it's just a matter of finding time. Okay, so yeah, we got the scale and transforms. So what does that actually do? So meta vertex control.x. It's pretty opaque. So okay, so it gets the static light map. Okay, so this is just applying the transform text macro. So it multiplies the scaling and then adds an offset. Right now needs to actually use incoming vertex position, so use it in a very dummy way. So if the position Z is greater than 0, then we use whatever real minimum is. So, and then it does the same thing for the dynamic light map. Oh, it's setting the position to the light map UV. Okay, I guess, yeah, because it's going to render directly onto the texture, I guess. But then it transforms to each clip. Okay, so these UVs must not be actual UVs. They must be something in world position. I need to look and see. Okay, and then anyway, so this does some magic here. Not very explained. And then okay, so in the fragment function, it has these same, okay, so it has meta fragment control. Alright, and then we take in the albedo, and then we clamp it based on some more math. Oh, so it applies the albedo boost from, oh yeah, so from the scene settings. Let me see here. Oh, right here. So this applies this option, I guess. Okay, and then, okay, so this is for emission. Oh, and then it has to transform to sRGB if we're not in linear space. Okay. So yeah. I mean, I guess I don't really have to understand what this means, but kind of useful. Yeah, so anyway, I think what I need to do is hope that Unity will apply these UVs to my soil mesh. And if so, I think I can actually just use these objects as is. Except on my terrain one, I'll have to, because I'll have to change the position based on the height. Oh, yeah, that's not even going to work with, well, I guess it will. Yeah, because since I changed the height and the fragment, hopefully I can edit this clip space position. I guess I can't really. Yeah, because you can't edit the clip space position in the fragment. Oh yeah, so this technique I don't think will work for that, for the texture, or for the terrain shader. So what I'll have to do, excuse me, is like tessellate it, and then, oh, it's going to be a mess. Unity has focused on making universal sample projects compared to HDRP. You must work with shader programming a lot, or just what you need for a current project. Oh yeah, they have focused on mostly universal, I think. But yeah, just some other stuff I've read seems like, I don't know, like Unity executives really like HDRP, but I guess it's just a matter of getting people to actually use it. But yeah, I do consider myself a tech artist, so probably about, well, lately, like 90% of the stuff I've been doing, our programming has all been shader related. All right, but anyway, how that terrain thing's making me sad. I don't know how I'm gonna get that to work. Might just not be able to. I don't know, I'll have to think about it, but let's just not worry about that for now. So hopefully, like I said, the light mapper will apply these UV1 and UV2 to my mesh, and then I can just use these already made functions. So copy this. Kind of like, so I have this depth only pass already, which just uses the default. Oh, actually, no, it does use my own depth only. Okay, well, never mind. I thought I used the ones that were included with the lighting. Okay, so yeah, if I do remember, yeah, you need to turn culling off for the meta pass, and I don't need any of this stuff. Okay, so let's see what happens when I try this. And I'm gonna make this soil object a lot smaller, so that in case that has something to do with the out of memory thing. Okay, so this is on, and all right. Let's try to generate lighting again. Okay, so that's a good sign. It's not freezing. Oh, except yeah, OBS is complaining. So sorry if my feed is kind of freezing for a second. Yeah, light mapping is probably not good to do while you're running OBS, but all right. Okay, so it actually ran. Let's see if I turn on the light map. Okay, did it work? If I take this soil, no, I just want it to be its own thing, and hide the visible one. Oh, it does look like it worked. Yeah, because this light map is on the soil object, and it doesn't look like it was occluded by the visible soil. Okay, that's wonderful. All right, so now let's see if I can transfer these light map UVs to the grass. Would trampling be hard to implement here? No, it's actually, well, I mean, relatively no. I've actually implemented trampling with a different project, and I'm definitely going to make a tutorial about that as well, but it'll probably be a separate video just because I just need to get this video out, and it's kind of self-contained as well, so. Great, so just to make sure everything runs correctly. Okay. So let's let me check how the lit shader, the forward pass works on that, because yeah, so it has the light map UV and text chord 1. So how does it get the shadow chord? So we can figure that out here. Input data. Oh, the way they wrote this is a little. Okay, so the light map UV, I have to call this macro, and then. Okay. Oh yeah, that's spherical harmonics, which I can actually calculate that, I think, in the actual grass shader. Yeah, who knows where these macros are implemented. I would like to find out. Okay, and then I can just say get shadow chord. Okay. And the fragment. Okay, so the shadow chord, yeah, it just passes it through. Otherwise, it can transform a world to shadow chord. Okay, so that's relatively easy. I can just do that in the grass shader. And the shadow coordinate is for... Oh, wait, no. I already do this. I'm looking for the shadow mask. Okay, so you sample shadow mask with the light map UV. Okay. Yeah, the shadow mask is for baked shadows. That's what I was trying to think. Okay, so screen space. I think that's for ambient occlusion, which I don't think I'll deal with right now. Vertex lighting. That's the spherical harmonics, I think. Let's see. Where did okay, what does it do with the spherical harmonics? So it puts them in a vertex spherical harmonic. I don't see it though. Oh. The output is in varyings, but how does that work? Because like here it says output vertex sh, but I don't see them here. We've got UV. Oh, okay. Here. Declare light map or spherical harmonics. Oh yeah, so it's storing those in text chord 1. So that's like if you're using, yeah, so basically the light map, well, we all know what that is. Spherical harmonics is another way that you can kind of estimate ambient lighting. Okay, so Unity only supports 1 at a time, I guess, which makes sense because yeah, if you're using light maps, you can just bake the spherical harmonics into the light map. Okay, so I really need to find out how, well, I guess I don't really. I can just call these functions and then whatever is given here, I'll just pass to the grass shader, right? Okay, so how does okay, fog factor and vertex light? That's what I was, because there's also fog chord. Fog factor. Okay, vertex light. How do I get that? Oh, here, vertex lighting. Okay. Yeah, and if that, I don't know if vertex lighting does specular, but that's another thing. Probably we won't be able to support specular lights for vertex lighting, but it might not even be factored in. So I think all this is in the lighting HLSL file. Yeah, so there's the light map stuff. Let's see here, get additional light. It's all fine. This is all lighting algorithms. Okay, ambient occlusion. Okay, so yeah, here's spherical harmonics, but I don't know when this is called. The way they basically have this correct function called kind of well, not really hacky, but they do it with like function overloads like this, where if a certain keyword is defined, it calls a different function, and it's really difficult to follow. But okay, spherical harmonic in the pixel shader. So here's light map stuff. Okay, that's the reflection cube map. Okay, so here you already have gotten the global illumination and you're applying it. Okay, so yeah, this is where it takes all of the specular and stuff, but I'm trying to find the vertex lighting function. That's what I was coming in here for. Oh, vertex lighting here. So additional lights count. Okay, so so vertex lighting, if Unity Unity only supports a certain number of lights in the fragment stage, so any other extra lights it shades per vertex, which is fine, but it's not as good quality. So I was just trying to see how they did it. They so you still get an additional light. Yeah, so there's no shadows, it's just the color and the distance attenuation, and then it does normal diffuse lighting on it. Okay. Well, that's good to know. But yeah, this can actually be, I'm kind of getting ahead of myself because this will actually be in the grass shader, not the soil. I should probably make a note of all this. So I want to do light map support. Okay, I don't have to write support. So I want to do light map, vertex lights. I should actually just do additional cone and spot lights. Let's do one at a time actually, because I don't think I support them. Lights, spot lights. I haven't even tested shadows either, but I'm pretty sure it should work. Maybe we should do one at a time here. So shadows, cone lights, spotlights, light map, vertex lights, spherical. and then baked shadows. Okay, so it sounds like a lot, but hopefully it actually won't be that difficult. We should try shadows first. That will be easy. So we've got grass here. I guess I need a shadow caster. Oh, it's like way in the distance. Yeah, let's move this ahead. So yeah, you can see the entire square. Okay, so yeah, it does get shadows, which is good. Obviously they don't look very good because there's no ambient lighting, so if there's anything in shadow, it's just completely black. But at least it does receive shadows from the main light. Yeah, so let's just change this to additional lighting. Okay, so cone lights should work. Oh, actually, no, they won't work because I think I removed additional light support from my... Well, I didn't really remove, I just took it out until I figured out how everything would work. So in this grass lighting, I need to... Yeah, so right here, we only do the main light. All right, let's close this. What am I looking for? Oh yeah, the lighting HLSL. So down here, so we have if def additional lights. And I can just move this over for now. Okay, and yeah, I'm not gonna do any occlusion for now. Okay, why do they do the plus plus before the light index? Just anyway, so okay, so yeah, if there's additional lights, then we find the number of additional lights, and then for each light index, we get so get an additional light based on the position and the shadow mask. Okay. And then I don't want to use this function because I want to use my new translucent lighting. I think all I have to do is pass in this input data, light and smoothness. Okay, I'm just gonna, I know this is probably a little slower, but I'm gonna change this just to match my programming style. Number of additional lights. Okay. So yeah, no errors. Now if I create I guess a point light. Okay, something went wrong. Undeclared identifier light index. Oh. Okay, that's off in the middle of nowhere again. Nothing's happening. Oh, it's because it's not visible. Let's move it here. And give it like a red color. Oh, okay, yeah, that it does work. That wasn't too bad. So we should get a cool. Yeah, my cat's been in here with me, so she's decided to talk for a bit. Anyway, so I was gonna say we should get some cool subsurface scattering. Okay, I think she wants out, so 1 second. All right, yeah, she just wanted out my room. Okay, so yeah, I'm trying to see. There should be like some subsurface strength from the lighting here, but it's probably just hard to see because I think the sun drowns it out. But I like the way the light looks. Maybe we can see it more in real time. Yeah, it's kind of hard to tell, but when the light passes behind the grass, it should change to subsurface mode. And I think it does, but maybe if I make it more intense. I don't know. It looks good anyway, so. Alright, so let's make another light. That'll be a directional light. Oh, is there any... Oh yeah, we should see if this point light will cast shadows before I move on. Unity just added point light support. Oh, actually... Okay, I'm in 20.3, so there's no point light shadow support in this version. Maybe I should... Well, for most of my tutorials, I want to support the most recent long-term support version as well as the most recent version period. So, and in order to do that, I kind of have to build it in the previous version and then test it in the current version before the video goes live. So yeah, hopefully, I mean, I haven't really changed anything with the shadow code, so hopefully it will just work. But we all know that well, this isn't a shader graph, but when I was trying to do all the shadow stuff with shader graphs, we all know how difficult that is. But anyway, but yeah, so there's no reason to test shadows here, but I think I'll make a note for me to do it. Spotlight, test shadows in 2021. Let's put one. Okay. So now, yeah, so let's make a spotlight. Again, it's out in the middle of nowhere. I'll make it blue. Alright, so I don't see anything. Oh, well. Okay, so now we should see that little bit. I guess I'll make the intensity pretty high. Okay, so you can see it on the ground there. Alright, so if I widen it, Let's delete, or not delete, I'll just hide that for now. I want to see if shadows work. Doesn't look like it. Yep, graphics. But no shadows. Well, at least not for this light. No, why? I'm not sure why that would be. Maybe I have to add another keyword. Oh no, I already have one. Let's check the lit shader and see what it has. Okay, so alpha test, blah, 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 blah. That's not what we need. Okay, so it has additional light, vertex, and additional lights. Additional light shadows, so maybe I have to use this multi-compile fragment. Okay, I'll just copy these over because I want to support all that stuff, except I don't really care about the screen space ambient occlusion. So we'll turn that off, but yeah, spotlights are real time, but I'm not, like, this is a real time spotlight, but I'm not seeing any any shadows. Oops. Because like right now, there should be a shadow underneath. Although, to be fair, there's not a shadow even on the ground terrain, which is just using, or on this dirt, which is just using a lit shader. Oh, I have no shadows turned on right there. Okay. But it's still not on. Let's see. Lighting per pixel. Okay. Turn it on there. Okay, there we go. I just hadn't set these options. Let's turn on cascades. Okay, so it still works with cascades. That's good to know. And soft shadows. Okay, yeah, so I just had to turn on this options. Usually I do that when I start a project, but I guess I just forgot. Yeah, so now we can see them. Yeah, they are on the grass too, not just the dirt. Okay, so that's good to know. And it still, point light still works. Okay. Let me see here. So we got cone lights. So I just need to test shadows. Okay, so light mapping. Let's make another spotlight that will just be part of the light map. Or point light, I mean. Let's move it over here. And I'll make it purple. And let's make it a lot stronger. Okay, so to make a light map, do I just have to turn on static? Oh, right here. This is what I'm looking for. Baked. Okay, so obviously you can still move it around in edit mode, but when I bake the lighting, it should be added to the light map. Oh yeah, this is, sorry, it's probably gonna drop some frames again in OBS. But thankfully it only takes about 20 seconds, so. Okay, so that seemed to work. Let's can I turn on that light map view and see? Okay, yeah, so that light does show up in the light map. UV charts. I was gonna see if I can see the light map UVs, but it doesn't really show. Is the grass supposed to cast shadows? No, I don't think it will. Well, I guess I could, but it's difficult to do double-sided shadow casting, so I'd have to add like another triangle to the back of them, of each grass blade, so it would double all the rendering. Okay, so now we can see with this baked light. Okay, yeah, so the purple light does show up on the dirt, but it doesn't show up on the grass blades. But yeah, because we don't support baked lights yet. So yeah, so that's what I started to set up. That's what I set out to do. Thank goodness it seems to be included. Our Unity does give us the light map UV. So light map UV and text chord 1. So I just need to export that into no, not that. Yeah, I'm looking for this file. So on this data that we sent to the sprouts, I just need to do another thing for I guess baked global illumination. Well, I remember I need to update the stride of this structure now in the sprout feature. So baked global illumination, and yeah, the structure is getting kind of big. We can't really. I think we could save one float on this tangent to world because I think, well, maybe not actually. I was gonna say maybe I think there's one value that's always 0, but I mean still. Unity hasn't complained to me about the structure getting too big, so can't really get rid of any of these values either, but anyway, kind of an aside. Okay, so we have the light map UV. So now I need to the lit forward pass. Oh yeah, we have to do those. Use all those macros to sample the light map. So yeah, it only gets the light map UV, but then we have fog as well. Yeah, I should probably test out fog. Okay, so the spherical harmonics. I'm not sure how I can get Unity to use those instead of the light map. Oh, I think I just have to like put out a ton of point lights, and then Unity will start to use it, like a lot of real-time point lights. I wonder if I can set. Oh, excuse me. If I can set the additional pixel lights and the additional vertex lights counts both to 0, then everything would be a spherical harmonic. So that's how I can test that. But all right, so got. What am I looking for? This is not the right thing. Okay, so yeah, it's this bit. And the reason I'm having to do them at the same time is because Unity either declares light map or a spherical harmonic. And I kind of want to know how this works. So let's go diving into the URP library. And yeah, the best way to find this is you have to just... Oh, here they do it. Okay, so that wasn't too bad. I was gonna say, you just keep on doing the find next until you find the original. Okay, well this isn't too bad. So declare light map. If the light map is on, then it just adds a text coordinate for the light map. Or, yeah, a field for light map. Otherwise it does the spherical harmonic. And then output light map UV. Okay, and then it does... Okay, so it has a scale and offset. Which, how do I know that? Light map UV. Unity light map. Okay, so it's just a global variable. Okay, so I think I can just use this macro again. Okay, so stays the same, except again, we got another thing here. So declare light map or spherical harmonics, and I'll put it in text chord 5. Alright, so here in the vertex stage, I think all I have to do is call those macros. Alright, so input light map UV, and then this global from Unity, and then I output it in the light map UV, and otherwise we take the normal world space and spherical harmonic. Okay, so that's all set up. And then here we just need to pass the whatever global illumination we have to the sprout. So okay, here sprout settings, baked global illumination, and then we'll add it here. Equal settings, baked global illumination, and okay, so back to the let forward pass and the fragment. I think it's actually part of the lit input. What was it? Okay, no, so it's a sample GI. Okay, so that's not too bad. And then the shadow mask I'll deal with later, but it's basically the same. That's true. The shadow mask, is that gonna have to be another? I think that might be another value that we have to put in that structure. People might have to, well, I don't know. At a certain point you have to choose, I guess, if we want to have shadow mask or maybe take out the color tint. I'm not sure. Anyway. Okay, so this should just take care of all that. We could just use the terrain normal, I think. Alright, so let's see if this gives us any errors. Taking quite a while to... compile. Oh, yeah, it's just complaining on the height that the big GI wasn't initialized. I'll just set that to 0 for now because yeah, I don't know if I'm even going to be able to use that. Anyway, so okay, so we have the Blake GI. Oh gosh, and I've got to leave, but I kind of want to see. Since we have the big GI, it should just work. Where is the... Here. All right, and then I need to add that to the structure. Okay, so we take this and I'm gonna have to pass it through both of these, I think. So this is to our tessellation, and then let's just copy this. Oops. Save a couple keystrokes. Okay, and then yeah, this has to be text chord 6. Okay. And then here we just pass it through. Yeah, and like I said, we can't like do this on the well, this might be a better way to do it later, but yeah, we can't calculate the big GI on the light. I mean, in this shader because Unity won't give this mesh a light map UV because it doesn't exist at edit time. But one thing I think I can save, because I was worried that I'd have to have the big GI and the shadow mask here, but I can also, can't I just pass through the light map UVs and then we can calculate everything else here? I mean, this might be, well, this actually might be faster because it only have to run once per blade instead of once per vertex, but it might be slower to have to pass around all this data. I don't know. That'd be an interesting thing to test. But anyway, so we have that here and I can just pass it through. So each vertex in this mesh has the same baked GI, so I can just use the, I don't have to interpolate. And then, okay, so I already have a baked GI set up. So hopefully if I just pass this through, it should work. I might have to press play. Oh. Okay, so what if I just pass that? Oh, okay. Well, that's a shame. I was hoping that it would just work, but unfortunately I am out of time, so we'll have to come back and fix this later. But I might change it anyway, because yeah, we can pass the, I think we can pass the light map UV into here, and then I can calculate everything in the vertex program, which will save up a lot of memory. So because I think otherwise I'd have to pass the shadow mask here. But I don't know. I'll see about that. But anyway, thanks everybody for watching. I do appreciate it. Thanks everybody for chatting too. It's nice to have some chatters with me tonight. But yeah, I'm pretty happy with the progress. I think next stream, which will be on Wednesday, I don't know if we'll work on this some more because I kind of want to move on to other projects, and now I have more time to work on this off stream. But I don't know. You guys let me know what you want to see. All right. Thanks, NTT. Good night to you as well. But yeah, I stream every Monday, Wednesday, and Friday at 9 Eastern time. So feel free to catch me here. And of course, I have a bunch of YouTube tutorials if you're interested in that. I'll put some links in chat. I also have a Discord where I try to be pretty active, so I'd love to have you there. But yeah, anyway, I'll see you Wednesday, and I hope you all have a great night. Bye-bye.